All right, let's do this thing. We're talking about the extreme value theorem and finding extrema of functions. And just to start off with, we'll look at what the extreme value theorem says. And it says that if f of x is continuous on a closed interval from a to b, then f must have both a maximum value and a minimum value. And when they say maximum and minimum, those are called extreme values. And what they're talking about are the greatest y value and the least y value. So maximum would be the point with the greatest y value. Minimum would be the point with the least y value. And it's important, like you can see here real quick in this little blue curve that I drew here from A to B, there's a minimum value all the way down here because there's no other points lower than it on this interval, and the maximum is up here because there's no other point. Now you can see over here, this guy right here might be some kind of special point as well, but he is not a max or a min on the interval. He's not the highest point on the interval. This one is. He is the highest point around like this interval right here, but we're not talking about that interval, so that's okay. But he is called a local maximum, and we'll get to that in a second. And it's important to think here, now there can be more than one maximum. The maximum point is a point that has a y value such that no other points are above it. They have no greater y values. And so like you could have a graph that has more than one maximum. Let's say we're starting here and it goes like this and ends here. Well, then we have two maximums right here and right there. There's nothing wrong with that. If you have a horizontal line from A to B, it's not very interesting, but if you have them like that, a horizontal line, well then every single point from here, from A to B, is a maximum as well as a minimum because no points are above each other and no points are below each other. So they're all maximums and minimums. Okay, so there could be more than one. Usually there'll just be one max and one min, but some functions have more than one. Not a big deal. And here I've drawn a whole bunch of stuff. The extreme values can occur at two places. So either at a critical number, which we haven't defined yet. You've probably heard this in class already. A critical number is a number where the derivative is either 0 or undefined. Okay, so a critical number for a function is where the derivative is 0 or undefined. That's not too complicated of a concept. And a critical number is where max and mins can happen, and they can also happen at the endpoint of a closed interval. So you can see here, in this first case, there are no critical numbers. This is like a straight line going on here. There are no critical numbers. There's no place where the derivative is 0 or undefined. It's just a line connecting two endpoints. So the min is down here and the max is here at the endpoints. On this curve here, from A to B, you can see that the maximum occurs where the derivative is 0. Again, a zero derivative is it's a slope of the tangent line. So you want a tangent line that has a slope of 0. And a line that has a slope of 0 is a horizontal line like that. And you can see at the top here that that tangent line at the very, very top point is going to be horizontal. Same thing down here. At this very bottom point, it's going to have a horizontal tangent line. So nothing crazy about that. It just says that if the derivative is 0, there could be a maximum or a minimum there. And in this case, there's one here and one here. In the third drawing, we have a maximum at a point where the derivative is undefined. That's a corner point up there. The derivative is undefined, and there's a maximum. There's also a minimum at an endpoint. Over here, we have a minimum at the endpoint here, the lowest point. And then the highest point on the interval from A to B is the point here where it's discontinuous. And again, if a function is discontinuous, then the derivative is not defined. So that is a critical point. And over here, we've solved this already. If it's a horizontal line, all the points are maximums and minimums because none are above the others and none are below the others. They're all the same y value. All right. So that's just a couple like little diagrams you can look at here to see what are the possibilities. So I mentioned this already. A local or a relative maximum, they mean the same thing. They're local and relative are kind of interchangeable here. Is a value that such that f of c is greater than all the other values of f of x on some open interval. So all that means is if you see this little piece of the function, there is a maximum value. That's called a local maximum. Now it doesn't have to be the absolute maximum. It doesn't have to be the highest point on the entire graph. Like we could have a graph that looks like this. Well, now if these ends both keep going up, then there is no highest point because they keep going higher up. No matter what point you pick here, I can always pick a point higher because it goes up forever. However, this point right here is called a local maximum because it's the highest point around itself. There's an interval that you can create around it, just like from here to here, say, and that's the highest point on it. Same thing with a local minimum or relative minimum. Same exact thing. It doesn't have to be the lowest point around, the lowest point on the graph. It just has to be the lowest point around itself in some window. So for instance, this point right here and this point right here would also be local minimums. But you can also see it, if this graph keeps going up forever on both ends, Well, then these 2 points here, if we assume they have the same y value, are the lowest points on the graph. So not only are they local minimums, there's something called an absolute or a global minimum. And that's all it means. It's just the lowest point on the entire graph. So it's the x value that gives you the lowest point in the domain of the graph. Usually we are more concerned with the relative max and mins, because what we're going to end up doing here is graphing equations or graphing functions and finding out where the maximum values are. So if you had a function like this, or the minimum values as well, like this, calculus, if we had an equation for this curve here, calculus is going to find this point and this point for us. And if you remember back in pre-calc, you spent a lot of time finding zeros of equations. You factored polynomials, you used rational equations, you did exponential and logarithms. You did all kinds of stuff finding out where functions equal 0. Well, now we're going to be able to find out where functions have maximum values and minimum values. So this is a very, very important piece here. The only place a function can have a maximum or a minimum value is at a critical point or a critical value. Okay, now that's not talking about endpoints. If you have a function that if you have an interval and you're looking at a function, then you can have a lowest point and a highest point at the endpoints. But if you're graphing an entire function, then the only place where a min or max could happen is at those critical numbers. So that really leads us to, there's 2 kinds of questions that you're going to be faced with in a calc class. The first kind of question, they're very similar. The first is going to say, here's a function f of x, here's a closed interval, determine if the extreme value theorem has to hold, determine if you can apply it, and if so, find the extreme values, find the maximum and minimums. Well, this type of problem, they give you a function, they give you a closed interval, and then they say find the extreme values. Well, the steps to doing that, very simple. Number 1, derive the function, find all the critical values. That's not bad. Derive it, set the derivative equal to 0, and then find the where it's 0 and where it's undefined. Once you have those points, they're the only possible places where a maximum and minimum could happen along with the endpoints. Okay, so we're checking critical values and endpoints. And you want to know what's the highest y value. Well, to find the y value, you just plug the x values into the function to get the y values. The greatest y value is the maximum, and the least y value is the minimum. It's as simple as that. And then if you're not given an interval, if you're just given a function and asked to find the relative extrema, then you don't have any endpoints to worry about. All you're going to do is derive the function, find the critical numbers, and we're going to use something called the first or the second derivative test. They're 2 separate tests. First derivative test, second derivative test. That's coming up later on. So right now we're really focusing on question number 1. Get a function, an interval, find the maximum minimum. So let's do that. Let's say we have the function f of x equals, I don't know, let's say x to the 2/3. Why not? All right, and let's say we're looking on the interval from -2 to 3. The question is going to be, find the maximum and minimum of f of x on this interval. Well, like we said, what we're going to do first is derive this function. F prime of x is 2/3 x to the -1/3, which is the same thing as 2 over x to the 1/3. Now, we're trying to find critical numbers, so we want to find out where is this thing equal to 0 and where is it undefined. Well, if we set it equal to 0, we're going to find out that no matter what x value you choose, this thing's never going to equal 0. However, this derivative right here is undefined when the denominator is 0, and that happens when x is 0. So our critical number, the only critical number we have, x equals 0. Okay? Now, step 2 is we're going to find the y values of the critical numbers and the endpoints. So essentially, we want f of -2, we want f of 0, and we want f of 3. That's what we need. When you plug in -2 to this thing, you're going to get -2 squared, that's to the 2nd power, that's 4, and then the cubed root of that. So it's the cubed root of 4. When you plug in 0, 0 to the 2/3 is 0. And when you plug in 3, you get 3 squared, which is 9. And then the cubed root of 9. So I have no idea what the cubed root of 4 or the cubed root of 9 is, but I definitely know which number is bigger. So the minimum on this interval happens at 0, and the value is 0. So it's the point 0, 0 is the minimum point. And the maximum on the interval happens when x is 3 and and the value is 9. So cubed root of 9, I'm sorry. So this is important as well. When you list these things, if it asks where does the minimum happen, that's the x value. Okay, so the x value is where the minimum happens, or where the maximum happens. And the y value is the actual minimum or maximum. Okay, so sometimes like on the AP exam or on a test or something, it's going to say where is the minimum value. Well, in this case, the minimum value is at 0. Or it might ask, what is the maximum value? Well, now the maximum value is cubed root of 9. If they asked where it was, that would be at x equals 3. Okay, that's the extreme value theorem. That's all it is. If you got an interval and a function, they say find the extreme values, you derive it, find the critical values, test the endpoints, and all the critical values. The greatest one is your maximum, the least one is the minimum.